In this video, we're going to be solving geometric problems. Here we have a vectors and shape question. OAB is a triangle. O to A is called A. O to B is called B. M is the midpoint of AB. N lies on OB, such that O to N to B is 1 to 3. So there's 4 parts. The whole journey is called B. So we've got 1/4 and 3/4. So we've got 1/4 of B and 3/4 of B. OM and AN intersect at P. We need to find the ratio O to P to M. So there's 2 ways of getting O to P. Well, there's probably more than 2, but we need 2. So we can say O to P is a fraction of O to M. So if we work out O to M, then we can say we've got some fraction of that. Or we could go 1/4 B and then some fraction of N to A. So we have 2 routes of getting from O to P, and then we can use simultaneous equations to solve it, to find out what fraction of the journey we have to go. Let's start by doing A to B, and then A to M will be half of that. So A to B minus A plus B. A to M is half of that journey, so minus a half A plus a half B. And then I can go from O to M. O to M is O to A, which is A, and then A to M, which is minus a half A plus a half B. So 1A take away half of an A is half of an A. So O to M is half A plus half B. That's O to M. O to P, so one of the roots, is it some fraction of that? So O to P, I'm just going to say is X times half A plus half B. I need another root. So I'm going to go O to N and then N to P. So I need N to A first. N to A is minus 1/4 of B plus A. N to P is some fraction of that. Let's use Y this time. Y times minus 1/4 B plus A. And then O to P is O to N and then N to P. So O to P is 1/4 B plus Y times minus 1/4 B plus A. So O to P, O to N, and then N to P. So now I've got O to P 2 times, 2 different times, and they must be equal. They're both O to P. So they must be equal, so I can make them equal to each other. I can say X times half A plus half B is equal to 1/4 B plus Y times minus 1/4 B plus A. Then I can separate out the A's and B's. I might want to expand first. I'll expand first. So I have half X A plus half X B equals 1/4 B minus 1/4 YB plus YA. So now I've got loads of A's and B's. I can make the A's equal the A's and the B's equal the B's. So for the A's, I have half X equals Y. And for the B's, I have half X equals 1/4 minus a quarter y. So I can say that half x is equal to y. So I can substitute half x into y. Half x is equal to y, so I can change this half x into y. So y equals a quarter minus a quarter y. Add a quarter y to both sides, so 5 quarters y equals a quarter. So y must be 1/5. So y is 1/5. So y is 1/5. What is x? Half x equals y. So if y is 1/5, half x equals 1/5, x must be 2/5. And x is what I wanted. I want the ratio OP to PM. X, where have I said what x is? X is the fraction of O to M that I wanted. So O to P is 2/5 of the journey. This is 2/5. O to P is 2/5 of the journey, which means P to M must be 3/5 of the journey. So the ratio O to P to M is 2/5 to 3/5, or 2 to 3. Okay, one for you to try. Pause the video and give it a go. OABC is a parallelogram, so the two opposite sides are equal. O to A is called A. O to C is called C. So A to B is also C, and C to B is also A. The point P lies on B to C, such that B to P is one part, and P to C is two parts. So it's 1/3 and 2/3, 1/3 of A and 2/3 of A. So C to P is 2/3 A, and P to B is 1/3 A. AP and OB intersect at N. Find the ratio O to N to N to B. We need to know what fraction O to N is of the journey O to B. So let's start with O to B. And we can say that is A plus C. And O to N, let's call our answer X. So X times A plus C. So X is what we want to find out. How else can I get from O to N? So I could go O to A, and then a fraction of A to P. So to do that, we'll have to know A to P. So A to P is C minus 1/3 A. So I can say O to N is A, and then a fraction of A to P. Let's call it Y. So Y times C minus 1/3 A. So I've got O to N twice by two different routes, and because they both go from O to N, they must be equal. So X times A plus C must be equal to A plus Y C minus 1/3 Y A. That's XA plus XC. So the A's must be equal, and the C's must be equal. And that one's an A. So we can write them out as two separate equations. So XA, and that's 1A minus 1/3 YA. And that's the second one is just X equals Y. So X is equal to Y. So I can change the Y into an X. So x is 1 minus a third x plus a third x to both sides. 4 thirds x equals 1. So x is 3 quarters. So O to N is 3 quarters of the journey. So it must be 3 quarters and 1 quarter. Find the ratio O to N to N to B. So it's 3 quarters and 1 quarter, which is 3 to 1. Here's a different question. We've got A to B is 7i minus 3j. So if we've got A, B is 7 right, 3 down. A to C is 2i, so 2 right, 7 down. So A to B is 7i minus 3j. A to C is 2i minus 7j. Find the sides of angle BAC. So there's different ways of doing this. I'm going to use the cosine rule this time. So to use the cosine rule, we need to know all 3 lengths. So we know A to B and A to C. We can work out their magnitude by using Pythagoras, but we don't know B to C, so we're going to have to work it out. So B to C is backwards along 7i minus 3j, and then forwards 2i minus 7j. Or we could say it's 2i minus 7j, so 2 negative 7 take away 7 negative 3. So 2 take away 7 is negative 5. Negative 7 take away negative 3. That's negative 7 plus 3 is negative 4. So to get from B to C, we're going back 5, down 4. So from B to C is negative 5i minus 4j. We can check that works. So if we go A to B and then add on B to C, we should get to C. So 7 take away 5 is 2, negative 3, and negative 4 add to make negative 7. Now we can work out these lengths. So just change them out of vector form. We just want to know the magnitude. So we use Pythagoras. So for A to B, magnitude of A to B is the square root of 7 squared plus 3 squared. Which is root 58. The magnitude of B to C is the square root of 4 squared plus 5 squared. Square root 41. And the magnitude of A to C is the square root of 2 squared plus 7 squared, which is root 53. So now we can just put it into the cosine rule. So the cosine rule for an angle, cos A equals B squared plus C squared minus A squared over 2BC. And we're going to have, so this is big A, so we've got little a, B, and C. So 5 and 4, that was B to C, that's A, and the other 2, B and C. So now we can just type it into the calculator. So we've got square root 58 squared plus square root 53 squared minus square root 41 squared over 2 times B, so root 58, times C, root 53. and make sure you close the bracket outside of the square root sign. So we've got 0.63. That's cos A, so shift cos our answer, and we get 50.9 degrees. Okay, one for you to try. Pause the video and give it a go. So O to A. Nine I minus J. O to B. 3I minus 5J. So what's A to B? So A to B is O to B, so the position of B, take away the position of A, so 3 negative 5, take away 9 negative 1, which is negative 6, negative 4. So negative 6I minus 4J. So then we could write these, their magnitudes. So O to A, the magnitude of O to A is square root 9 squared plus 1 squared, which is root 82. The magnitude of O to B, square root 3 squared plus 5 squared, which is root 34. And square root 6 squared plus 4 squared, the magnitude of A to B is 2 root 13. So we're working out AOB, so that's big A. Little a is our 2 root 13, A to B, and the other two in any order are B and C. So cos A is equal to B squared, so root 34 squared, plus C squared, root 82 squared, minus A squared, I'll write 2 root 13 squared, all over 2BC, so 2 times root 34 times root 82. So type it in the calculator. 34 plus 82 minus 2 square root 13 squared over 2 times root 34 times root 82. So we've got 0.606, shift cos the answer, and we get 52.7 degrees. I'm going to have a go at the same question, doing it a different way. So A to B was 7i minus 3j, and A to C was 2i minus 7j. We wanted to work out angle BAC, so that's this angle here. So we can work this out using SOHCAHTOA twice. So if we work out the angle AC makes with the x direction, and work out the angle AB makes with the x direction, we can take them away from each other. So we could work out this total angle here, which is the angle AC makes with the x direction. That's part of this right angle triangle here. And then work out this little one here. We could take one away from the other. So we could use SOHCAHTOA twice. So for the yellow triangle, we've got the opposite and the adjacent. So it's tan. So it can be tan theta is TOA. So tan theta is 7/2. Shift tan 7/2, 74.05. And I'll store that as A. For the other triangle, we've got the angle there, so the opposite and adjacent. Tan theta is 3/7. Shift tan 3/7, 23.2. And if we do the big one, take away the small one, so that was A, take away our last answer, we get 50.9. And that was the same as using the cosine rule. If you want to try, have a go at doing it this way, pause the video and give it a go. So O to A is 9i minus a j. O to B is 3i minus 5j. So we want to work out the size of angle AOB, which is this here. So we can work out this yellow angle and take away the white angle, and it will leave us the red angle. So for the yellow one, tan theta is TOA, opposite over adjacent. So tan theta is 5/3. Shift tan 5/3, 59.0. Store it as A. For the white angle, we've got opposite and adjacent. So tan theta is 1/9. Shift tan 1/9 is 6.34. So the red angle is 59.0, take away 6.34, which is 52.7. And just check back, that's the same answer as we got for the last question.